Okay, so these are two formulas that we need to get comfortable with. And I just had a meeting this morning with the math department, and this trainer really wanted me to make sure you know that by the time you get to her class for honors pre-calc, she needs you to have the formulas memorized. So in my class, I have posters around the room, but she really wants you to get used to taking tests without having access to formulas. So if I can start helping you now, like memorize it, then it'll just kind of pave the way when you get to her class. Because she says on like AP tests, you don't get to use a note card or anything. Okay. So the first formula has a squared term in it, which means it's for quadratic functions. I'm just going to make a note. This formula is for quadratics. This formula is for absolute value functions. Okay, so I'm going to explain a little bit what each of those variables represent, mainly the A, the H, and the K. And it's going to make it so much easier to graph. We still kind of need a table, but just not as much. So the example that I want to do from your packet, I mean, we could do any of them, but I'm going to do number 7, and just look at another one. Yeah, I'll do 7 and probably number 10. So for the homework on the Delta Math packet, there's not a lot of room. That's why I want to do it on this note, this paper. So let's just transfer the question over here, but then you can do the graph in the packet because it's already got the graph for you. So I'm going to do y equals, there's a -2. This one is an absolute value function with the quantity x minus 3 and then a plus 5. Okay, so these are just the formulas up top. Now we're going to apply it to a problem. And the question is, graph the function. So we're not going to use Desmos. We don't need it. And we're not going to make a big table either. We'll make a small table, not a big one. So first thing I want you to do, it's kind of like graphing a linear function. I was making you write out like M and B, kind of the same idea, but you're going to write out the A, the H, and the K. Every problem is going to be in the form of one of these two functions. What I like to do, you don't have to, is I just kind of write the formula. You could write it above or below. This is the general formula. So if I write it below, I kind of have an idea what my A is. So on this one, my A is -2. Soren, what are you looking for? Thanks. The A is -2. And then what's my H value? This one's a little tricky though. Is it 3 or -3? 3. 3. So in the formula, that minus is there. That means if I'm asking for the H is 3. But especially when we get more complicated problems, the formal way to determine the H is you're going to set what's inside the absolute value equal to 0. So I'll make a note about that. I'm going to write that. I think I'll do it right here. So I'm going to put a note to find H. I'm going to say set the expression, basically like the absolute value expression. I should have put that first. Set the absolute value expression equal to 0 and solve it. These lines mean absolute value. Let me move that up, sorry. Okay, so we're going to go +3, and that is why we get a positive. So by saying x equals 3, we're really saying the h value. Okay, now we're going to identify the k, which the formula says plus k, so my k value is positive 5. Okay, these are new variables. I'm assuming you haven't heard those letters before. H and k, does anyone know what it represents for the function? It's a very popular point on the graph. It's a special point. It could be an intercept, but not necessarily, because it could be shifted. It's a vertex, yeah. So the h and k, if you put those together, the h represents the x coordinate of the vertex, the k represents the y coordinate. Always, this is the formula, that it's a pattern that works on every single graph. So now I know that my vertex for this problem is, I'm going to make actually my pencil's not very strong. I'm going to use this one. I'm going to make an x and y table. And since I know my h is 3, my k is 5, that means, so I'm going to write 3 comma 5, or just 3, 5 in the table. That is my vertex. That means I have other points on both sides of that point. The vertex splits the graph in the middle. So remember when we were doing the graphs the other day and you were like, well, is it just random points that we pick? Not necessarily, because now we know that 3, 5 is the vertex. So I don't want to pick 4, 5, 6, 7, 8, 9, 10, because that's only going to give me one side of the graph. I kind of want to pick a couple, but even then, what's really cool about these graphs is they're symmetric around the vertex. So if you know one point, you can reflect it and you've got the other. So we really don't need to make a table. So let's practice graphing this over here. I'm going to bring the graph of number 7 up. We know the vertex is at 3, comma 5. So I make a point. Now there's one other variable that we haven't talked about, which is the a. What does the a do to the graph? Any ideas? It's kind of like a slope in a way. If it was linear, it kind of represents slope. But what is the a going to do in this one? It's going to stretch it, because we just learned that the other day, because it's a 2. But what else is going to happen? Flip it. Yeah, reflect it. So instead of my graph opening up, it's going to, I just kind of predict it's going to go somewhere around here. And it gets a little narrower. So the best way to figure it out is just make a table. Pick another point. Instead of 3, maybe I pick 4. Or I could go down and maybe I try 2. This is really just your choice at that point, but I would want to show a tiny bit of the algebra. So I'm going to go y equals -2. And then I'm going to plug in 2 minus 3 absolute value plus 5. So if I really simplify this like step by step, here's how that would look. I would go -3 times the absolute value of -1 plus 5. And I don't need you to write out every little step if you can do some of it in your head. But I want to show you why it's going to be -2 times +1. Because some people, if you go too fast, you might think this cancels out to a positive. It doesn't, because you're taking the absolute value, that comes first. It's kind of like an exponent. You got to do that part first, then you multiply, then we add. So all of this is going to be -2 plus 5, which is +3. So now I get the point 2, 3. Okay, that's probably the most amount of work that we have to do. So I'm going to go back to my graph and we're going to plot 2, 3. So now what I found is that that's the left side of my graph. So that means like I'm going to draw a dashed line through the middle because my vertex is the middle. I do it just for the visual You don't necessarily have to, but since I know this graph is upside down from the parent function, I know that the other point must go right there. It's a reflection.
Can you also just go down too?
Yes. Okay, so that's what I was just going to say. We don't have to do any more points because Max noticed, like with these absolute value, they're kind of linear, right? Like on each side. So this one went like down to left 1. So I can just keep going down to left 1. There's your other point. And then guess what? This point is reflected on this side. So I also can just like count like, okay, well there's 2 units from the line of symmetry, and then here's 2 units. So the whole idea of symmetry is like you fold it along that line and those points will map onto each other. So you really don't have to do a lot of algebra. But it really helps to have your graphs like, you know, on these printed ones. And so now I can connect. And it's a little easier than doing a table, because with a table, you don't know where to start. And this formula is called graphing form, so it really helps you identify the vertex from the beginning. Okay, let's try one more, and then I want the rest to be on your own. I think I said I'll do number 10. Yeah, I want to do 10 because that one's a quadratic. So we just did an absolute value. Let's do number 10, which is y equals -2, another -2, but that's fine. X squared plus 3. So one thing you should always look out for is sometimes your h is 0, sometimes your k is 0. In this case, which one is 0? Is it h or k?
H.
It's the h. How do we know? Well, the plus 3 at the end, go ahead.
I was gonna say there's no like parentheses.
There's no parentheses. So really what they did is they simplified this equation. It's kind of like saying this, -2 times x minus 0 squared, and then a plus 3. Since the plus 3 is not in the parentheses, that's how we know that the 3 actually is outside. It's a k value instead. So you just have to sometimes look for it, because you'll get to a problem and then you're like, wait, I don't know how to find the h. Or sometimes you don't have a k value, so you have to put 0. So do like what we did up here. I want you to write out the a, the h, and the k. The a value does help you a little bit with the graphing, but more so it tells you if it's a stretch, if it's a compression, or if it gets reflected over the x-axis. So it's more of like a visual cue. We don't necessarily use it yet when we're graphing. We mainly go for the h and the k. So now we know, what is my h again? 0. What's the k? 3. What's a? -2. A is just whatever's in front of the squared part, which is -2 again. Okay, so let's go ahead and graph 0, 3. So I'm going to make a note that my hk is equal to 0, 3. So in that case, it's an intercept. Let me make an x and y table. 0, 3 is in the middle because that's my vertex. Let's go ahead and graph it. So I'm going to move over to my paper. 0, 3. Okay, so let's use the a value. Let's try to make a prediction. Where is it going? Up or down? The graph. Sophie?
Down.
Down. So I shouldn't see any points up here. I know it's going to go somewhere like over here, but this one's a quadratic, so it's curved. It's not the, you know, the linear kind like the absolute value. So now I just pick a point. Instead of picking 0, just pick whatever, like on either side. You could pick 1, you could pick 2. Really doesn't matter. So maybe I just pick +1. So I go y equals -2 times positive 1 squared plus 3. That would equal negative 2 times 1. So this is the exponents first, right? You have to do this part, and then plus 3. So now you get negative 2 plus 3. Well, that equals positive 1. So 1, 1 is my next point. I'm going to graph it. 1, 1. Okay, don't forget these are not straight. They're curved because it's a parabola. But you can't really draw the line of symmetry because it's going to just go on top of the y-axis. But what we could do is, like, we can start it, like we know it's going to go like that. So that means there's another point here. I don't need to check that. I know there's a point on that side. Now, the only reason I'm going to keep going, I forgot to mention, like on Delta Math, they want 5 points. So we got to go with 2 more, but we really only need 1 more because then you can reflect it. So let's just test another point. Let's plug in 2 and see what happens. So I get y equals negative 2 times 2 squared plus 3. So then I get negative 2 times 4 plus 3. Was it? Oh, you already got the answer? Yeah, it's negative 8 plus 3, which is negative 5. So I've got 2 comma negative 5. Let's just see how it looks. Two comma negative 5. And then, so it's 2 units away from the line of symmetry, so we know there's another point on this side. So now I can finish my graph a little bit better. And you're good.